Okay, let's get started. So we started talking about projection bias last time, which is my favorite topic in behavioral economics, and one that I think may have particularly large sort of normative implications for individual decision making. If people fail to predict that the way that their preferences will change over time as a result of something that we could model as a change in state, hungry to not hungry, I don't know, single to married, young to old, then we could potentially see people making big mistakes. What we're going to do today is we're going to take two different approaches to looking at the implications of a simple model of projection bias for individual choice and potentially market outcomes. And those two different approaches should be familiar to you as sort of two of the main ways that economists sort of apply their models or use their models or think about the world. One of the things that economists really like to do, and actually it's one of the ways that economists get in trouble the most, is we really like to do deductive reasoning. We really like to do this trick where we make some assumptions about the big wide world and how people behave, and we may be more or less rigorous about how we test the validity of our assumptions, but we're going to make a bunch of assumptions, we're going to mathematize them into a model, whether it be simple or complex, and then we're going to make predictions about the world, and then we're going to stop. And we're going to say, oh, we're done, we've learned something about the world. Okay? We made some assumptions at a micro level, we made some predictions about the world, and that was our form of investigation. We learned about the world, we learned about what must be true in the world, right? If I write down a model of utility function that captures rational, monotonically increasing preferences, and I assume that all goods are normal and that nothing's a given good, I get downward sloping demand curves. I don't have to go out and explore whether or not demand curves are downward sloping. I got that out of my model, I'm done, I've observed the world through my model. Okay? Which is literally the way economists, that's literally what we're doing. We're not saying this might be the way the world is if these assumptions were true. That's what we should be doing. But what we're actually doing is we're doing what's called deductive reasoning, which is we're saying because we decided these were reasonable assumptions, therefore it must be the case that this is what's going on in the world. Because you've got to hold this a little bit lightly. But that's the first thing we're going to do. Is we're going to crank up a very simple model of the demand for durable goods or consumers' preferences for durable goods, and we're going to say if the assumptions of this model are valid, here's what must be true in the world. And then we're going to take a fundamentally different approach, and we're going to say let's actually take our model to some real data and find out whether or not it's true. Right? So we're going from the micro to the macro in one case, and we're going from the macro to the micro in the other case, in sort of inductive reasoning if you want, actually testing the model to see if it's true. Okay. So here's a couple of stories about durable goods, and these are my words. I'm going to show you a model of what I call shiny object bias and the pack rat effect, which is, I probably shouldn't trivialize these things because I think they could actually have fairly significant impact on our society. So here's what we're not going to do today. In the reading that's assigned, Lowenstein, O'Donoghue, and Wright in 2003, which I think is just called projection bias or something like that, they do this with durable goods. They say, if you have fluctuating demand, if your preferences are some days high, you really want the iPhone, and sometimes low, I'm not that into the iPhone today, then your demand, and if we assume that how you feel about the iPhone is going to be roughly the same once you bought it. There'll be days when you're really jazzed about your iPhone and days when you're like, oh, I could be just as happy with a Motorola. Then your willingness to pay for the iPhone should be some kind of average, right, of how you feel on high demand days and low demand days. But if you have which is some kind of state-dependent variation in your preferences. But if you have projection bias, then roughly speaking, what the paper sort of models is somebody who on high demand days thinks, I am somebody who loves iPhones and I always will be, that's the deal. And on low demands you think to yourself, I am not an iPhone person, I have not been hoodwinked by this foolishness, and I don't care about iPhones. And what happens is on low demand days, you're safe from your projection bias because those are days you don't want to buy the thing. On high demand days, you think, I'm always going to love this, I'll pay any price for it, you go out and buy it, and then you regret your choice on low demand days. So that's what they do with this model. We're going to do something slightly different, which is going to get us kind of similar results, but for a different reason, which is we're going to say, what if we look at projection bias over reference-dependent preferences, right? So this is basically taking us back to Mugs and Money, and what we saw was that people tend to demand too high of a price for a good because they don't want to lose it, and what if we're finding the model? They tend to deflate their buying price, right? Because their buying price isn't as high. Their buying price isn't as high as their selling price because the buying is just a gain, whereas the selling is a loss, and they care more about the loss in the gain. What we're going to see is when you then crank this up into a intertemporal model, where the person is going to own the durable good for many, many periods, and their reference point is going to adapt. So they're only going to feel this gain or loss utility for one period, maybe a couple periods, and then they're going to adapt and get used to having or losing the good. If they don't foresee that, they have projection bias with respect to that adaptation, that state change, what happens to their willingness to pay for the good? And what we're going to find is that they inflate both their willingness to pay when buying and their willingness to accept when selling, and then we'll look at what happens in the market. Okay, so here's a simple model. It is marginally less simple than the model that we got familiar with in the first couple of weeks of the course. But this is the model this sort of reflects the sort of more standard model of reference dependence these days in this following way. Okay, so this person has preferences over some durable good D and money Y, and then at any point in time they have this consumption vector, a certain number of units of the durable good, which for simplicity we're going to think about 0 and 1, either you buy it or you don't, or you sell it or you don't, and then YT, which we could normalize to 0, and that's just going to capture their buying price and their selling price. Okay, and then we're going to let them have reference dependent preferences with respect to the durable good, and their reference point is going to be based on lagged consumption. Okay, so just super simple, this idea that you get used to things over time. And then for simplicity, we're going to assume no reference dependence in money. It doesn't affect the results of the model. It just makes the math easier. Okay, so let's have the instantaneous utility function be this. And here's the addition, right? So there's money. That's not reference dependent. Here's gain or loss in the durable good, right? Let's call it an iPhone. So this is D of DT is going to be 1 or 0, and RT is going to be 1 or 0. So either you're gaining a mug or you're losing a mug, or you're just staying steady, right? So if you gain a mug, you get K, and if you lose a mug, you lose lambda K, right? And lambda is this coefficient of loss aversion that tells us how much more you dislike a loss than you like a gain. So what's different in the model is this, which is that for having any given number of iPhones, sorry, I've got mugs stuck in my head, that having an iPhone not only gives you the gain-loss utility of either, oh, I got a new thing, or oh, I lost my iPhone, but in addition, you get 4 utils that I just haven't, right, because you get to make phone calls, okay? And that's not going to depend upon your reference point at all, so that's not going to change with adaptation. That's just your use value, or the instrumental value, if you want, or sometimes referred to as consumption utility of the iPhone itself. Okay. And then we're going to just assume complete projection bias, alpha equals 1. And and we want to see what will happen to willingness to pay for buyers and willingness to accept for sellers. Now, we're doing, as always, we're comparing, like looking at the buyer. This is someone who doesn't have a mug, even if they doesn't have an iPhone. So we're going to just have their reference point be 0. Now, they might be iPhone collectors, and we will just normalize their reference point to how many they've got now, and we'll just subtract off how many they've got now, and we'll call it 0. So not buying a mug, not surprisingly, is going to give them a utility of 0. And then what we're going to do is we're going to compare that, as we have over and over again, to the utility of their other possible option, which is to buy a mug. I keep saying mug. Maybe I should just switch to mug. No, it's an iPhone. It really is an iPhone. Okay, so what is the buyer's true utility from buying? So this is, we're not interested in what they think it is. We're sort of, you can think of this as, imagine that the person had no projection bias, alpha of 0, or you can just say, what's the truth? Forget the individual's brain and their beliefs. So what's the actual truth? So if she buys, she gets 4. That's just the instrumental value of having an iPhone. Plus k times 1 minus 0. So that's the what I call the shiny object. That's like, oh, I got an iPhone. That's nice. And then she has to give up the buying price. Okay, she gets that in the first period. And then the following period, her reference point changes from 0 to 1 because now she's got an iPhone. She's adapted to it, right? She still likes making calls on it and Googling in the middle of arguments so she can win, and things like that. But she doesn't get any gain-loss utility. Okay, so she gets 4, that's the use value, times k minus 0, because she's adapted. And then we're modeling money as non-durable. We're assuming that this is a durable good, and everything else that you might have spent your money on was not durable, would just be consumed period by period. So you're only going to feel this utility from the buying price one time. Okay, so what this means is that she's going to get that 4 utils every period from then on. Okay, and we're going to, I didn't write this down, but we're just going to make the math work, we're going to assume that she has regular exponential discounting. If you don't have any discounting, you wind up with big problems here. So we're going to assume regular delta discounting. So the utility from not buying is 0. And that we want to find the buying price that sets that equal to the utility from buying, right? Which is this thing, 4 plus k minus pb, the first period utility, whoops, plus this sum. The sum from t equals 1, and we're just going to let this be an infinite time horizon because it's going to make the math work, of the discounted value of owning that phone, the use value of the phone, the 4. Yeah? Okay. Now, let me remind you of a very useful mathematical fact, which you, I think, have learned somewhere along the line, which is that the sum of an infinite series from some time period 0 out into the infinite future of delta to the t times some constant a is equal to what? Does anyone remember? I had to look it up on Wikipedia this morning. It's a over 1 minus delta. So this is a really simple little modeling trick. If you are ever doing stuff where somebody is weighing an immediate cost against a long-term stream of constant gains or losses, or positive or negative sums, it's just make it infinite and make the discounting exponential. Okay, and then you don't have to, the summation goes away and things are not messy. So then what's convenient is that here's 4 is our a, right? But here the sum starts at 1, but we got 4 over here in period 0. So that's the same thing as k minus pb plus the sum from t equals 0 to infinity of delta to the t times 4. And that's just equal to k minus pb plus 4 over 1 minus delta. Now, depending on what delta is, 4 over 1 minus delta may be pretty close to, like if delta is very, very small, someone's extremely impatient, then 4 over 1 minus delta may not be that different from 4. But if someone is reasonably patient, say a yearly delta of 0.95, then 4 over 1 minus delta is quite a lot bigger than 4 because this person is recognizing that they're going to get this sort of infinite stream of use value out of the iPhone. Of course, it's not infinite because the iPhone is going to become obsolete after a few years, but it's just a rough approximation. So we want to find the negative p, the pb that makes the utility from not buying 0 equal to the utility from buying, which is this thing. And that just tells us that this person's buying price should be 4 over 1 minus delta plus k. Okay, so what is that? It's the discounted value of an infinite stream of use value, or winning arguments at the dinner table, plus I've got to be compensated for k. Sorry, I'm willing to pay to get k. This is a one-time shiny object effect. It's going to be fun in that first period to walk around saying, "Oh, look at my new iPhone. Yeah, it's pink." Okay, and so this reference dependence very slightly inflates the willingness to pay for this thing. Okay. However, if our consumer is projection biased, then things are going to be quite different. Obviously, the utility from not buying will be the same, which is 0. This time, however, so she gets the same utility in the first period. She gets 4 for the phone, loses the money, and then gets this gain bump k. But then she thinks that her reference point isn't going to change, and that her reference point in all future periods will be 0 instead of 1. And that means that she thinks she'll get, and I'm deeply apologetic, this is wrong, and it was wrong last year, and I just did cut and paste, and so it stayed wrong. She gets the 4 for the phone every period, plus she thinks she's going to get k times 1 minus 0, because she thinks her reference point is going to stay at 0, plus 0 in terms of money, and that's equal to 4 plus k. Right? So her utility, we could say her utility from buying, or what she believes her utility from buying will be, is just 4 plus k minus pb, that's in the first period, plus this sum from t equals 1 to infinity of delta to the t times 4 plus k, right? That's what she thinks her future discounted stream of utility is going to be. And so I'll we can take that 4 plus k and stick it inside there, and I won't write out the summation again. What that is it's 4 over 1 minus delta plus k over 1 minus delta minus pb, right? Which means that she needs well, I don't want to do that. That's right, that'll be confusing. So she needs, she's now willing to pay a pb of up to 4 over 1 minus delta plus k over 1 minus delta. Okay, so that's the action in the model right there. Is that her willingness to pay just went up by the amount, k over 1 minus delta minus k, right? That's the upward, that's the inflation factor, if you want, or that's an unfortunate term. That's how much her projection bias inflates her willingness to pay for the iPhone. And again, if delta is sort of reasonably close to 1, this could be potentially quite a large number, right? Now, you could argue that someone who is so spaced out about the future in terms of projection bias should also be pretty spaced out about the future in terms of discounting. But I think it's not unreasonable to think that there are situations in which people foresee, like have patience about, oh, yes, I'm going to be thrilled about my iPhone for the rest of my life, but don't foresee the change in their state-dependent preferences. Yeah, David. Sorry, can I just ask the person who's taking photographs? It would be better for me if you had checked in before you. Oh, you're taking pictures of the screen? Okay, fine. As long as you're not taking pictures of me. So you're saying why is the 4 discounted? Because she's getting it in every period from now to an infinite time horizon? It's not that she's unable to predict her future utility. It's that she's unable to predict her future state-dependent change in utility. Okay, so her preferences for the phone, it's for the use value of the phone, that 4 times dt, the actual utility of having the phone, that's not state-dependent. Okay, so if, let's say, for example, that she was currently on vacation and really out of touch with friends and family, then her use value for the phone might be 8. But she's only going to be on vacation for a month, and she's going to come home, and her use value will go down to 4. Projection bias would be if she buys the phone thinking that the infinite stream of use value is going to be 8 over 1 minus delta, instead of 8 discounted over the first month and then 4 over 1 minus delta. But we've set this model up so that her use value of the phone isn't state-dependent, so projection bias doesn't have any bite. Right? Alpha times some number plus 1 minus alpha times that number is just that number. There's no, we could model her as, we might be able to say, in fact we should say, that she has projection bias over all dimensions of state dependence. So it's not just that she mispredicts changes in her reference-dependent preferences. We could say she mispredicts changes in all of her preferences. It's just there isn't any change in her preferences with respect to the use value in this model. Yeah, that's a really important distinction. It's not that she's rational with respect to the use value. It's that because the use value is not changing with her state, there's no room for projection bias to cause problems. Okay. Alrighty. So now we can do the same thing for the seller. And I'll keep it simple because the math is very much the same. Okay. So the seller's reference point starts out as 1, and it's going to change to 0, but in the next slide we're going to see her failing to predict that. Okay, so if she keeps the durable good, doesn't sell, she's going to get the use value. So this is someone who has an iPhone and is trying to decide whether or not to sell it. And apparently this is an iPhone that has not taken a lot of wear because the use value hasn't gone down at all. It's still basically brand new. So her utility from not selling is 4 over 1 minus delta. And her utility from selling is going to be, she's going to get the selling price, and then she's going to lose lambda k 1 time. Right? That's the, oh, I had to give up my iPhone. That's not, I had to give up the use value of the iPhone. That's the, oh, I just hate losing things. I hate having to give things up. Okay? And she only gets it 1 time. Okay? So her selling price is going to be 4 over 1 minus delta, or should be, rather, plus lambda k, which is, she's got to be compensated for giving up the infinite stream of the use value of the phone, and she's also got to be compensated for 1 period of sort of loss shock, right? Whatever you want to call that. And not surprisingly, just looking for pens to stop moving. Not surprisingly, I won't even walk through all this, but basically what's going to go on is the same as before. She thinks she's going to lose that lambda k of loss utility in every period. She thinks it's going to suck to give up her iPhone forever, or that it's going to suck forever to give up her iPhone. And so what we're going to wind up with, and I'll just cut to the chase, and you can fill in the math yourself if you want, is that her actual selling price is going to be 4 over 1 minus delta plus lambda k over 1 minus delta, because basically she thinks that she's going to be suffering a lifetime of pining for her lost iPhone. Okay. So I'm calling that the pack rat effect because you could imagine that contributing to the tendency for people to never want to clear their stuff out and take it to Goodwill or sell it on eBay, and so they wind up with stuff stacked up the rafters. That's actually not an exaggeration or a joke. It can get very, very serious for some people. Okay, and then I sort of was saying that the situation where people inflate their willingness to pay for a durable good, I'm calling the shiny object bias, right? Because it's like, oh, another shiny object. I'm going to love it forever. And it's like, I love it for a week, and then you realize, my goodness, they had a shocking amount of money on that. I remember this happening to me when I was about 8 years old. I was looking at the FAO Schwartz catalog, and they had a Snoopy dollhouse. Snoopy's, you could get a dollhouse that was Snoopy's doghouse. And, I don't know where this came from, but I just became completely convinced that the Snoopy dollhouse was going to solve all of my little 8-year-old problems. And, and so I spent all of my pocket, like $24, which when I was 8 was a lot of money. And I just somehow managed to convince my parents to let me spend my entire saved up allowance on this thing. And I got lucky because FAO Schwartz lost my order. I never got the doghouse. I've had other experiences with doghouses, but that's a different matter. Okay, so now let's see what happens when we take, right, so we've done what we classically do with models of consumer choice. We model the individual, now we're going to aggregate up to the market. Okay? So how would this change the standard model of supply and demand for reference-dependent durable goods? What is the single biggest, most salient, and important result of the standard rational model of supply and demand for consumer goods? What is the thing that model tells us that is like sort of arguably the most important impact of microeconomics on our society? Bingo, that the equilibrium of supply and demand, of consumer willingness to pay and producer willingness to accept payment for producing will maximize total social welfare, right? It's a sort of it's not exactly the first fundamental welfare theorem, but it's a sort of fairly direct